Where do we find wound-induced de novo roots? Well, with the majority of plant species, the phloem ray parenchyma cells are going to be the most important area for reasons I've already described to you. There are also other areas, too, described in the literature where you can have de novo adventitious rooting occurring as well, too. The cambial and phloem portions of the vascular ray tissues can be another area as well. And a lot of times when you're working with a woody plant species, it's really kind of difficult to kind of discern where are these roots originating from, and you have to take a whole bunch of sections, and you got to get it in the right developmental stage to be able to do that. And working with woody tissue is really difficult because it's very difficult to make good stem sections. So a lot of times it's really difficult to pinpoint where the exact location is. But of those areas, the phloem ray parenchyma is going to be extremely important, particularly with most plant materials we deal with. When it comes to more difficult to root plant species like spruce, picea, like pines, pinus, and what have you, there, for instance, rooting can take place from what's known as callus. It can be internal and external callus, and those are what are known as irregularly arranged parenchyma tissues. And again, what happens is that at the base of a cutting, when you go ahead and you take a cutting, there's what we call a wounding effect that goes on. And if we look at this picture here, the base of it is actually at the top there. I kind of reverse things. But where the arrow is pointing to is an area which is becoming meristematic. There's cell division going on. There's calluses occurring here. And later on, there's going to be a root primordium that forms from there. For roots to form from internal or external callus, the process takes a lot longer because a lot of things have to work right if you're going to be successful in getting roots to form. And that's why with more difficult to root plant species, the rooting process typically takes much longer because there's a lot of cellular events that have to work right if the process is going to go on. Here's an example of some stuff here. If we take a look at the juvenile and mature form of Ficus pumila, one of the things about juvenility and maturity is that when a plant is in the juvenile form, it tends to be relatively easy to root. And with certain woody plant species, as they become mature, they become more difficult to root. And as I mentioned to you, there are physiological changes that go on. There are also these epigenetic types of changes that go on. It's kind of like us, when we get older. You guys can't see me, but I don't have a lot of hair on the top of my head. But I was born with the same genes as a baby that I currently have right now. But what's happened is, as I have aged, for instance, my skin has changed, it's gotten more wrinkled, I've lost hair, and all this other stuff. The genes are still the same. My gene population hasn't changed at all. But the ability of certain genes to be turned on and certain genes to be turned off has changed as I have aged. The same thing goes on in the plant system as well, too. They have the same genes when they're juvenile as they do when they're mature, but certain genes get turned on and certain genes get turned off. And Dr. Clark has given you an earlier lecture where he went through some of the biology and gene manipulation and what goes on here. But here's a good example of some practical aspects of gene manipulation and how that becomes very important in the rooting process. So again, there are certain genes that are to be turned on or turned off that makes a plant, when it's physiologically mature, have much more greater difficulty in being able to root and regenerate and form cuttings. And again, from a commercial standpoint, if we could have the ability of being able to go ahead and manipulate things genetically, we could potentially take an elite specimen tree, or whether it happens to be for ornamental characteristics or for timber production, and go ahead, go through a tissue culture system, go ahead and insert certain genes which are involved in that process, and then just use traditional cutting propagation systems to mass produce it. There's that type of potential and that type of interest in that area. All right, if we take a look and make a comparison between juvenile versus mature, again with creeping fig, here we have first anticlinal cell divisions occurring in the ray parenchyma. And one of the things you'll notice is that with the juvenile material, it occurs 2 days earlier than the mature. So there's a difference, a time sequence that goes on that's different there. When it comes to actually seeing full-blown primordium occurring, that was going to be stage 3. In the juvenile, it occurs in about a week's time. In the mature material, it takes longer. So with the mature material, this whole process, there's a lag period that's taken longer than with the juvenile, easy-to-root stuff. First rooting. By first rooting, we're basically evaluating was when 25% of the cuttings have rooted. in terms of when 25% of the cuttings have rooted in the juvenile material, that happens very quickly within a week's time. And with the mature material, it basically takes 3 times longer for 25% of the cuttings to have gone ahead and started to root. Much longer process. When it comes to maximum rooting, basically where all the cuttings have gone ahead and rooted, it's a 2-week process with the juvenile material. It's a 4-week process with the mature. So again, the whole lag period is much longer with the mature material. One of the things that's kind of interesting here is, if you'll notice, even though that it takes longer, it takes basically for 7 days to 20 days for first rooting and maximum rooting 14 to 28 days. One of the things that you will notice is there's basically a 7-day gap between first rooting versus maximum rooting in the juvenile. If you look at day 7 for day 14, that's basically 7 days. And if you look at the mature day 20 versus day 28, that's a little bit more than 7 days, but pretty close to it. The point being here, the earlier events occur much more quickly with the juvenile material, but once you start to see rooting occurring, when you get 25% rooting occurring, there's basically just a week's gap. So it's those early events which are really important in the rooting process. All right, auxins. Auxins are these phytohormones. I'm going to be talking more about phytohormones in my next presentation, but they're really important in stimulating rooting. Here's an example of powder talc formulations of auxins, and we still use those today. And they're basically, you buy them commercially. And one of the things I want to mention is that for those of you who get involved in working with the industry, there may be temptation to go ahead and make up your own auxin concoctions and what have you, but you always want to make sure that whatever auxins you're working with have an EPA label. That's the Environmental Protection Agency label. And that's very important because auxins, as a straight concentration, are a pesticide, a very strong pesticide, and so it's really important that you use formulations which are approved. All right, another and probably more important aspect of applying auxins is through quick dips, and sometimes we'll also use sprays. Quick dips are typically done from 1 to 5 seconds, and here's an example of spraying auxins on. There's some commercial nurseries which will go ahead and they'll actually spray auxins onto the cuttings. And again, you can get an idea what that looks like, and it's very fast and very simple to use that type of a system. The quick dip system of 1 to 5 seconds, as you're seeing on the right-hand side there, is probably the most common way that we apply auxins. And a reason a lot of people like that system is that there's much greater uniformity. With talcs or powders, for instance, you've got to be real careful because you can lose some of that talc and powder as you insert the cutting into the propagation media. With liquid formulations, you normally have more uniformity of response. One thing that some producers will do is sometimes they'll use combinations of both a quick dip, where they actually dip the material in an auxin, and then they'll go ahead and they'll also put some talc on. So sometimes they use combinations. And one of the neat things about propagation is there's really no one best way of propagating stuff. There's a whole lot of different techniques that one can use. And actually in the plant propagation book you use in the course, Hartman and Kester's book on plant propagation, in the last 3 sections there's really good practical chapters on how you use auxin concentrations, the type of auxins to use, the concentration levels, and again, what's the best way of applying these auxins. In terms of auxins, the most important ones are going to be what's known as indole butyric acid. We call that IBA. There's also naphthalene acetic acid, NAA, and these auxins are used either alone or in combinations in commercial propagation. They're the 2 most important auxins for us. Here's an example of Dip and Grow, and I'm not pushing any particular product, but it's a common one that's used in the industry. It's a concentrate, and it's composed of both indole butyric acid and naphthalene acetic acid. It also has an EPA regulation. And again, in your plant propagation textbook, there's a list of a lot of other commercial products as well too, which also would have EPA labels. And you can go ahead, you can buy these concentrates, and then you can dilute them down, because you're not going to use a very high concentration of auxin. You're going to typically dilute it down to a much lower level. One of the tricks of the trade that people will use in the industry is actually working with food dyes. And the whole idea behind a food dye is, let's say, for instance, I'm working with 1,000 parts per million, and I've got some other cuttings that I'm working with at 2,500 parts per million, and maybe I've got some other cuttings I'm working with at 3,000 parts per million. It's really easy to confuse concentration. So one of the ways that certain growers will do is they'll actually use food dyes. You can buy those at the local supermarket and go ahead and put those in the respective concentrations you're working with, and then that's much easier for your employees to know that, hey, the green colored one is the one I want to go ahead and work with when I'm dipping these junipers in auxin. So again, these food dyes are very common, and you can purchase a slick way of being able to make sure that you're using the right concentration of auxins. One of the things that's always impressed me about the nursery industry, greenhouse industry, is how clever a lot of producers are. There's some really, really intelligent people out there, and they're very clever about how they develop things. This happens to be something that Charlie Parkinson out of Virginia, Lancaster Farms, developed. And what you've got is bundles of cuttings which are bundled up in rubber bands of 50 cuttings per rubber band. And what he's devised is actually a system there where there's actually a trough at the bottom, and that trough will have a solution of auxin which comes out there. So he can go ahead, basically put all these bunches of cuttings out there, and then in that trough there's basically auxin which is allowed to go ahead and sit in the bottom of that trough. And then you'll notice, for instance, he's got a vacuum system at the bottom to go ahead and drain that off. It's a way of mass dipping cuttings on a very large scale. One thing I might mention as well too is when you use auxins, we typically only like to use the amount we're going to be using for that day. At the end of the day, if we have some auxins we've used, for instance, we tend to go ahead and dispose of those properly. We don't want to use those again. Another thing too, for instance, in Florida and in Texas, it gets really hot in the summertime. So what's going on in the summertime with a chemical solution? You have a lot of evaporation going on. That means that your concentration levels can be changing as well too. They can become more concentrated. So again, what we typically like to use is just enough for being able to go ahead and work with the cuttings at the time we're working with it. And then at the end of the day, we basically dispose of those auxins that we have, that we've used, and so we don't have to worry about contamination or not having the proper concentration the following day. In the industry, one of the things that has been tried, this is what's known as Hare's rooting powder, and a lot of times people use strictly just auxins. Well, with Hare's rooting powder, what they were doing is using what we call kind of a cocktail approach. They were looking at more than just auxin, because even though auxin is a phytohormone that we use all the time for rooting, we know that auxins are not the only thing involved in the rooting process. There are a lot of other metabolites which are involved in rooting as well too. I'm going to be talking a little bit more about rooting cofactors in my next presentation, but rooting cofactors are materials that can act synergistically with auxin. That means that there's kind of a multiplication effect that goes on, and in certain plant species it's been shown that there are cofactors which can actually enhance the rooting process. It doesn't occur in all plant species, but again, it's just an example of where more than one chemical is involved in the rooting process. They're also using a sugar, in this particular situation, sucrose. And again, the rooting process is a really high energy deriving process. Respiration rates are really high, so that's why they're using sucrose in this situation. They're also using a fungicide. This happens to be captan, which is a very common fungicide. And they also have some growth retardants as well here too. The idea behind using a growth retardant is if you think about rooting, well, where's this rooting occurring? It's occurring at the base of the stem. Well, that's a real energy deriving area. And in plants we have what are known as competing sinks. And what that means is it's kind of like the kitchen sink, where everything kind of just drains down to the bottom of the sink. Well, when we have a high metabolic event going on, when we're trying to go ahead and produce meristematic areas, when we're trying to get roots to go ahead and form, that really causes, or there's a big need for a lot of metabolites and energy to occur there. Well, if we also have shoot elongation occurring at the same time, that's what we call a competing sink, because it takes energy for the shoot elongation process to go on as well, and that really kind of diverts metabolites. So the whole idea behind using growth retardants was to really kind of shut down shoot growth so that growth could be focused more on rooting. So again, this might be a cocktail that you use that you experiment with, particularly if you're working in industry and you've got a really elite specimen type plant, but just using auxins is not helping. You might go ahead and consider using a cocktail approach like this. In juvenility and maturity, I've already mentioned that as a plant becomes physiologically mature, it's more difficult to root. What you have is a picture of Ficus pumila. The mature is to the left, the juvenile is to the right. After 40 days, you notice the mature, when it's not treated with auxin, essentially has no rooting occurring here at all, where the juvenile is rooted very, very profusely. One of the things about auxins is they will speed up and they will enhance the rooting of cuttings. But the plant material has to have the genetic potential, it has to have cells which have the sensitivity to be able to respond to the stimulus of auxin, to be able to go ahead and root. And not all physiologically mature plant materials have that sensitivity, that ability to respond to auxin. Difficult to root species or cuttings taken from physiologically mature stock plants may not respond to auxin. So again, this is a big problem that the industry has to face. And again, in our particular business, where you make money is not producing the same cultivar of juniper, the same whatever species you happen to be working with. What you're really making money on is coming up with new cultivars, new selections. So if you come up with a very unique cultivar selection, but you cannot commercially propagate it on a large enough economic scale, even though it's a great looking plant which has tremendous potential, if you can't commercially propagate it on large enough scales, it's not going to be a commercial success. So that's why there's a big interest in this in our industry to go ahead and improve and enhance rooting of cuttings. This whole idea of plant biotechnology, as I've alluded to, we have genes which are responsible for making the plant tissue respond to auxin, and there was a really nice study that was done in France a number of years ago, and they were actually able to isolate those genes which are involved in producing auxin, and also those genes which are involved in the sensitivity of cells to respond to auxin. And what they found in that study was it wasn't the ability of the plant to produce auxin, it was the ability of certain genes that get involved in allowing the plants to have sensitivity to auxin. So what's that telling us is that we have auxin involved, but we have other factors involved in having commercially successful rooting occurring. There are also seasonal effects in rooting occur as well too. And again, if we look at Ficus pumila here, looking at the mature material, at the bottom we have a graph that goes from J being January, February, March, all the way through October, November. And you'll notice that at the very bottom there, we have a negative IBA. What that means is that's the control. There was no auxin, there was no indole acid applied, and the only months that really have any decent rooting are going to be like in April and May, and after that it's pretty much flat. When we go ahead and we apply auxin, an optimal level of auxin, and if you look at the top graph there, you'll notice that the level of auxin is much higher, actually reaching 100% a number of different months there. You'll also notice, though, that January and February in the top graph, the highest it gets is 40, and it goes between 20 to 40%. So what that's showing is there's a seasonal response that goes on even when we do apply auxin to the mature material. Again, mature being more difficult to root. With the juvenile material, if you look at the bottom graph there, where no auxin was applied, that negative IBA, you'll notice that, again, there's seasonal responses that go on. Rooting, of course, is much higher than you'll find with the juvenile material, but there's still seasonal responses that go on. January and November, for instance, happen to be very low rooting months with the juvenile material. When we apply the auxin at the top there, you'll notice that essentially everything has in the area of 80 to 100% rooting. Statistically, there's no difference in any of those months when we apply auxin to the juvenile, easy-to-root material. So the take-home message from this all is that there are seasonal effects that go on. Those seasonal effects do affect both the mature and the juvenile material. Those seasonal effects are probably much stronger with the mature material. And if you look at the use of auxins, auxins will enhance rooting with both the mature and the juvenile, but the greatest enhancement of rooting actually occurs with the juvenile, easy-to-root material, where by using auxin, you overcome seasonal responses, seasonal effects. One of the things we've looked at also has been shoot RNA and seasonal effects, because timing becomes critical. And in the video that we shot in Orlando, one of the things that we talked about was timing. You know, what's the best time of the year to go ahead and collect cuttings? And good nursery people, good propagators, are very astute. They really live with their plants. They have a really good feeling, like if I'm taking a softwood cutting or if I'm taking a semi-hardwood cutting, these are the characteristics I'm looking for. The wood's got to be this certain color. The bud has to be this certain shape or form. The leaf has to look like this. They're very astute in how they do things. And we're always looking for cues that we can use, because the whole idea is when we take cuttings, we want it to be during the time of the year where we can maximize the rooting process. Because again, in a nursery, in propagation, in a greenhouse operation, you are paying space, you're paying rent, you have fixed and variable costs that you're dealing with, so you want to make sure that things go as efficiently as possible. All right, some of the things that we did here was actually looking at shoot RNA and seasonal effects, and this is the apical meristem, this is the shoot apex, and that's the apical dome, and you've got two primordium that are on top. And what we did is we were looking at seasonal effects to see how that gets involved in the rooting process, and if there were certain things we could key in on. If you look at a time of the year where there's very low rooting occurring, and this was a particular stain that's being used here, and that stain is being used to actually stain for RNA, there is very low RNA activity that's taking place in the shoot system during times of the year when rooting is very poor. And during optimal times of the year when rooting is very high, there's a lot more RNA activity that's taking place during high periods of the year. So again, there's some indirect effects that are going on here, seasonal effects that are going on in the shoot apices, which are also ultimately influencing what goes on in the rooting process as well. One of the things I might make a plug for here is Aggie Horticulture. It's a great website. It's a great website from the standpoint of being able to link up and get information on a lot of stuff in horticulture, from tissue culture to extension type stuff to ornamentals, you name it. It's a great website, and I'm going to go ahead and post it here.